I will. So what we're looking at here, again, you didn't need to graph them. Just the asymptotes and holes. So please take a look at what I've got. There wasn't that much work on numbers 1 and 2. Just a little bit of factoring on 2. Questions on those? First ones were kind of nice. So much easier when you don't actually have to graph it, right? You don't have to find all the points and plug them in and give yourself a headache. So here's 3 and 4. Again, please, when you do the hole, actually give me the coordinate that hole would be at. Oh! What happened? I really hate it when you people say that. You made a silly mistake.
I mean, it's a very silly mistake.
No. All right, so are we okay on number 4 with the slant asymptote? And actually, make sure that you have the y equals 4x minus 10. You okay with the slant asymptote? Make sure that the slant asymptote is in the equation of a line, like y equals 4x minus 10. And then here's the answer to the last 2. I will show you how to do the long division, but that's all you needed.
No, I did the long division, and I just gave up.
Yeah, no. You got it all right? Good. So for the long division, all you need to do is if you are lining up your variables, all you need is you go to where you have no more numbers and you can stop.
Oh, wait.
This is why you line the x's up, you line the x squares up, you line the x cubes up. Because when you put it in there, you know you're done because you have nowhere else to go. And that makes it confusing, right? So work on that. Make sure that you get them lined up. It makes life a heck of a lot easier. Okay? All right, so were there any other questions on the warm-up? Good? All right. Now, I'm really hoping today is a day that you guys go, yes! I hope so. This can be difficult if you overthink it. So our goal here is to not overthink it. What we're talking about are something called limits. Now, a limit is what your function goes to. So what we have here is, here we have a function, x squared minus 1 over x minus 1. And I can say, what's going to happen at x equals 1? There's a couple of different things. If I were to look at this, I could factor the top. What would the numerator become? X plus 1, x minus 1 over x minus 1. What would happen? And so what would we call that? A hole. So we have a hole when x is 1, and when I plug that back in, what's 1 plus 1? 2. So I can say that at f of 1, I actually don't have a value. It's going to be undefined there because we have a hole. But what we can talk about is we can say, let's pretend we take that spot out of the running entirely. You cannot see what's there. We can talk about what happens really, really close to when x is 1. And that's called the limit. What does it look like it's going to? I don't care what actually happens there. I only care about what does it look like it's going to. So that is determined by saying the limit. The limit as x equals 1 is, as x goes to 1, is saying, okay, as I move on the axis towards 1 for x, what does my corresponding y value end up becoming? 2. That's what a limit is. The limit is not saying, oh, well, at 1 there's nothing. The limit is saying, as I go closer and closer to 2, what does it look like? Does that make sense? That's all a limit is. So, you have three choices when we talk about limits. We can say the limit does not exist. And that's because it goes to different numbers from both sides. We can say the limit equals a number, which is what we had from right here. And that's because it comes to the same number from both sides. Or we can say the limit is infinity. And this sounds kind of weird that I'm saying this, but I do mean it. They go to the same infinity. What do I mean by the same infinity? Right, they either go to both positives or both negatives. So let's take a look at this graph. I want to know the limit as x goes to -2. So that means I don't really care what's happening at 2. So I'm covering up what's happening at 2. But as I come to 2 on this side, what is my graph going to? 1. As I come to the graph on this side, what's it going to? Since from both sides it's going to the same number, the limit is 1. But I can say here that f of -2, if I were to actually look at my graph and say what's happening at -2, what would you tell me? 3. Okay, so this is where the limit and the function are two different things. The limit's saying if I cover up what is actually happening at -2, what do I think it's going to go to? I don't need to know exactly what's there. The function says all I care about is what is actually happening there. Okay? So then if I look at the next one, it says what is the limit as f of x goes to -1? So as I go to -1 here, what's my height going to? 3. As I go to -1 here, what's my height going to? 1. Are those the same? No. So the limit does not exist. Okay? And if I were to talk about for this one, f of -1, what is f of -1? It's undefined. It does not exist. It's a restriction. It's not. What kind of a discontinuity is that? That's a jump discontinuity. What kind of a discontinuity was this? A whole or removable discontinuity. So removables have limits. Jumps don't. Okay? And if I were to look at this last one right here, as x goes to +1, what is my graph going to from this side? Infinity. What's the graph going to this side? You see, those are both the same infinities. It's not positive and negative. So that means what is the limit? Infinity. Although again, at this point, f of +1 would still also not exist, because there's not going to be a spot here where it's going to touch my graph. Okay, what kind of a discontinuity is this? Infinite. It's one of my asymptotes. Okay? Does that make sense? That's the main idea. We're going to tack one little thing onto that. That's pretty much it. Like I said, this one's going to be, if we don't overthink it, it's okay. So the only thing I'm kind of tweaking here is one-sided limits. Guess what that means? You look at it from one side. So this is going to sound weird. Is that number a -1 or a +1? This is saying -1, and the +1 here means from the right, because the positive side is the right-hand side. So I'm going to take a look at just that graph. I'm looking at -1. And as I come at it from the right-hand side, what does it look like it's going to? Just guesstimate. That's not 1. It's like, okay, I'm going to say 0.8 because I'm lazy. You can say 3/4 if you want, show off. Okay, so I'm going to look at that to be 3/4 or 0.8 or whatever you want. As I go to that value, and you see this here still says -1, but that negative sign on the right-hand side means come at it from the left. So as I'm coming at -1 from the left, what does it actually look like? 3. Okay? And just as a quick little reminder, if I were to kind of pull that off and take another look at that, what is f of -1? 3. Is that function continuous right there? No. What kind of a discontinuity is it? We have a jump discontinuity. And if I asked you the overall limit, would the overall limit exist? Like if I just said the limit as x goes to -1 of f of x, what would you say? Does not exist. Okay? And it's just that idea of a limit is I don't care what's actually going on there. I only care about what's happening on the left hand versus the right hand side. So, is this going to be a one-sided limit or an overall limit? Overall limit. So as I approach 0, which one's my sticky end? There it is. As I approach 0 overall, what is my limit? Does not exist. Because from this side it's going to 3, from this side it's going to infinity. Now if I look at the next one, what is this talking about? One side. Which side? So all I care about is that piece of the graph. What is my function going to? 3. Okay? And what does 3 talk about? On the left-hand side. What's it going to on the left-hand side? Infinity. So what we have here is this limit does not exist because infinity is not the same thing as 3. That's why the limit does not exist. Left-hand side, right-hand side need to be the same thing for a limit to exist. So the next one is talking about 1. Is it an overall or is it just a side? Overall. So what is the overall limit for 1? 1. And that is because if I come at y from, which side is this? The left. If I look at it from the left, what is it going to? And this one is saying, on the right-hand side, what's it going to? And because these two are the same, we do have a limit. Okay? So I want you guys to try 7, 8, and 9. How is this so far?
Yeah.
You can say whatever you want. Guesstimate. It ain't pretty. And believe it or not, I think my answer on that was the same thing. So what is the... number 7 is talking about which limit? The left-hand limit. So what is the left-hand limit? Yeah, I did 3.4 was mine also. If you had something slightly different, as long as you didn't say that was 3 or 5, okay. Or 4 even. 5 is definitely not it. What's this one talking about? From the right. What's the limit from the right? Jayden, 3.5. Okay, and the overall limit, 3.4. Okay, when those two are the same, you get that. There's one last thing that I want to talk about, and that's the definition of continuous. For something to be continuous, let's just go ahead and write it on here. If I ask you whether or not something is continuous, you have to be able to say the overall limit as you go to that number is the same thing as the function at that number. So if I were looking at this picture here, at 2, the overall limit, so both directions come to that place that's about 3.4, right? Left and right go to 3.4, and the point there is 3.4. Is it continuous there? Right here, is that continuous? On my graph, do I have to pick up my pencil there to draw the graph? No. That is continuous. If I look at the next piece, as I come to like 1, if I'm going down to this, what height am I getting at? If I come to this, what height am I getting at? But what is the function at that point? 2. Is the limit and the function the same thing? So is that continuous? No. And that's how we define whether or not something is continuous. If they ask you to say, if I ask you a question using the definition of limits, is the function continuous? You would say not continuous because the limit as x goes to 1 of f of x is 1, but that's not f of 1, which is 2. Or you could say the limit as we go to 1 is 1, the function at 1 is 2, those are not equal. So it's not continuous. Does that make sense? Okay, let's put it all together. I want you guys to do 10 through 27. This should be, I know it sounds like, oh my gosh, she's asking us to do so many problems. They should go extremely fast. Go for it. All right, let's take a look at our answers for this. Looking at the first group, as we go down the side, 2, 3, D, N, E, 0, 0, 0. It's like a song. 2, 3, D, N, E, 0, 0, 0. No, not a cool song? Questions on 10 through 15? No. I was listening, Jaden, to what you were saying on 27. It's a positive 4 that you're looking at there from the left-hand side. So that one does exist. If I had said negative 4 from the left-hand side, it would have been does not exist. Please, guys, let me know if you have questions on these. Do you have questions on these? Are you sure? Well, you look like you're gonna fall to pieces. Okay. Leanne, yes.
So for like the 26 0 overall.
26 for 0 overall. Remember, we don't care what's actually going on there. We're saying as we come to 0. That's why I do that, because it's not about what's happening there in reality. It's what's it going to look like. It's kind of like the movies. It doesn't kind of when they make movies not based on what actually happens, but based on what they think is going to happen. I might think it's going to be a really big success, and then it's a bomb at the box office. Like Green Lantern.
Green Lantern's stupid.
They thought it was going to be a huge success.
Did they really?
It really wasn't. Yeah. I actually kind of liked it. I kind of liked it. I like Ryan Reynolds, though. He's a cutie patootie.
Wait, who?
Ryan Reynolds.
Oh, yeah. I agree.
She's like,
I
Ding, ding. All right. So, questions on those? Seriously. So, I've got some practice that we're going to do together. Okay. So, for number 1, what'd you get? 5. Number 2? 5. So, if I were to say what f of 0 would be, what would you say? 5. Is that continuous? Yes. And you can tell by looking at the picture, I can draw that whole thing without picking up my pen. Okay, and the limit overall is 5 also. What about number 4? 2. Number 5? 6? Does not exist. Is the function continuous there? No, because the left and right don't match up. What is number 7? -1. So for that one, the left and the right are the same, but what is f of -3? So is f continuous at -3? No. And the reason why is because what we had for number 7 was not what we had for number 8. Okay, those were not the same numbers. Okay, what about the limit as x goes to -4? 1. We already talked about 3. Is f continuous at 3? No. And again, it's because that overall limit does not exist. Is f continuous at 4? Yes. Good. Now, let me just kind of clarify what's going on down here. It's just instead of having numbers, you've got letters. So as I go across this graph, this is the a value for x. What is x here? 0. This is b is x, c, d, and e. It's each of those points on the axis. Then the heights, that's f, that's g, that's h. What's this height? 0. That's I, and that's j. So, this first thing is actually talking about the infinite limit. If I were to just go on and 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 on forever this direction on my graph, what is my graph going to? F, because you see here, my graph is leveling out. That's my asymptote at F. So the limit is F. What about if I were to go the negative direction? If I'm going out this way, it's going to be F also. It's not G because G is already, we're past G already. Okay. Now we're looking at from to A from what side? For 15. On the right, what's it going to? Infinity. It's going straight up. What about as I come to A from the left side? It's looking like it's going to I. What about the overall limit? Does not exist. Good. Now I'm going to be approaching B. If I approach B from the right, what is it going to be? Infinity. If I approach B from the left, J is the height. And the overall approaching of B does not exist. See, this is more confusing because there's no numbers, but it works the same way. You just got to kind of figure out what it lines up with. So the overall limit for C, good. Overall limit for D, 0. If I were to actually look at my function g at A, remember I drew that point in, so that point wasn't there. Where is g at A? It doesn't exist because here's a hole, here's an asymptote. So that does not exist. What about g at B? Good. G at E? G. And G at 0? H. Very satisfied putting of pencils down. So, on the other side of that is your homework assignment for this lesson. So, we have a ton of time. We have we've got a half hour to finish. You guys have that time to finish both of your homeworks. Okay, both worksheets.